Hello students, welcome back to my channel. So today we are going to start a new series of physics where we are going to study all the fundamental concepts of physics from the absolute beginning. So today's subject is distance and displacement. In this series we will cover all the basic of physics that you need to know that sets the foundation of your physics concepts. So let's start with distance and displacement. Now the basic question about what is a distance? Distance is basically the the length that a body travels from one point to another. The path in between two points is known as the distance, the path in which we actually travel. For example, here in this example, a body starts from the point A and crossing all over PQ, it reaches the point B. So its total length is AP plus PQ plus QB, which is mentioned over here. That's as part of this diagram, the body travels from from A to P, from P to Q, and then from P to Q to B. So the total distance that a body travels over here is AP plus PQ plus QB. Now this is a scalar quantity and distance can never be zero, because whenever you are traveling from one point to another, distance is equal to zero makes no sense, right? Distance is equal to zero means the body has not started traveling. Like when it is at its very starting position, then only we can say that the distance is zero. Once the body starts moving, then only its distance starts recording, right? Because for example, you're moving from your house to school, so there should be some distance that you're traveling. It is not that there's no distance, so distance can never be zero. You always have to start traveling in order to calculate the distance, and it can never be zero, it can never be negative as well. It's always a positive number. Why? Because you cannot go, even if you go to from your house to your school and then from your school back to your house, but you're traveling some distance, right? It's a scalar quantity. There is no it only has a magnitude, it doesn't have a sign. It is not a vector quantity, it's a scalar quantity, because you only measure distance by its magnitude. There is it's, let's say, 5 kilometer, 10 kilometer, whatever it might be, it can only be a positive number, it can never be a negative number, it can never be zero. So that is about distance. Now let's move to displacement. Now what is displacement? Displacement basically means that you have started from the point A, you have reached the point B via, let's say, P, Q and all. But displacement says that we are not going to see whichever path you have traveled from. While going from let's say from Kolkata to Delhi, you are traveling in between. If you go to London and then come back to Kolkata, that is not come back to Delhi, that is not my lookout. You can start from Kolkata, you can go to London, you can go to wherever place in the world and then come back to Delhi, but your point of travel is from Kolkata to Delhi, right? So we are going to take the shortest distance between Kolkata and Delhi, and that would be your displacement, because you have already displaced yourself from Kolkata to Delhi. That is your starting and the destination point. We don't care about whichever places you have moved in between and whatever things you did in between. That is not my lookout. My lookout is only that you started from this place and you have reached this place. That is known as displacement. It gives it in a given direction. It is a distance traveled in a given direction is called displacement. It's the shortest length between 2 points. So we are only going to consider the shortest length between these 2 points. So here it starts from A, it reaches B, and that is my only point of concern. I don't have to concern whichever path I'm taking. I might take this path, I might take some other path, I might go to absolute end of the world and then come back to B. That is not my lookout. My lookout is where I started and where I ended. So in this given diagram, we have taken the very same diagram that I've explained, that I've used while explaining distance. So for the very same path, my displacement will be AB, and displacement can be zero. How? Because whenever you start from a point and if you return back to the very same point, then your displacement would be zero. Here I've explained why displacement can be zero but distance can never be zero. This is a very vital question. You will definitely come across this question in your school or in your exams. Surely this question is going to come. What they say is that when a body starts from one point and after traveling returns to the very same point, its displacement is zero, but the distance traveled cannot be zero. What does that mean? That That means, let's say I've started from the point A, I've moved all this path, and then I've reached B. Now A and B are the very same point. Let's take the example of house to school. Let's say you started from your house, you went to your school, and then after that you have returned back to your house. So in the morning at, let's say, 7 a.m., you are in your house, and at 10 a.m., I'm considering, you're again back to your house. Now in between this time, you have went to your school, you came back from your school, but when I am looking, I'm finding you at the very same point. You start at 7 a.m., I've seen you, you're in your house. Next at 10 or 11 a.m., or at night in 7 p.m., I've seen you same in the very same position in your house. So your net displacement is zero. You might have traveled a lot, you might have traveled the entire day, but you're coming back to the very same point. So considering that condition, your displacement is zero, but you have traveled a lot of distance. So I cannot say your distance is zero, distance covered by you is zero, but I can definitely say that your displacement is zero, because I have seen, last time when I saw you, I have seen you in the very same point where I'm finding you currently. So it clearly depicts that distance cannot be zero, but displacement can definitely be zero. For this diagram, the starting and ending point is same, so the displacement is zero, but distance is equal to the total length of the path traveled. So distance basically means it went from here, then all this path across, and you might have covered 10 kilometers the entire day, but that would be your distance. Your distance would be 10 kilometers. You have traveled this much during the day, but your displacement would be zero, nothing more than that. So here I have just in a tabular format, I have listed down the difference between distance and displacement, just what I have explained right till now. Distance is the actual length of the path traveled by the particle in a given interval of time. So it gives you the total length of the path that a person or a body traveled, whereas displacement is the shortest distance between the initial position and the final position of the moving particle in a particular direction. Second is, distance traveled by a particle in a given interval of time is always positive, while displacement of the particle in a given interval of time may be positive, it can be negative, it can be zero. Now the question might come, how come it is negative? For example, we have started from, in the previous diagram, you have started from here. You went all through this path, and you have stopped, let's say, here. If you consider this direction as your positive direction, this is your negative direction, right? For, let's say, you have started from here, you have moved all this, and you have reached this point, this arrow top button point, this point, let's say this point. This point, you can see it is not in the right direction, it is towards the left of the starting point. So if I consider this right side as my positive side, the side where I started traveling with, then this point is definitely my negative point. So if I stopped somewhere over here, my displacement would be negative. Why? Because I've started from here. If I consider this direction as my positive direction, then this should be my negative direction. It all depends on the direction that I'm taking. I'll come to more on this later, while we are going to study velocity or speed and velocity. During that time, I'll cover this part as well in detail. But for now, let's just assume that displacement can be negative as well. If we consider one direction as a positive, and if the body stopped in the opposite direction, then we can consider that displacement is negative for that case. We have already seen displacement can be zero, and obviously it can be positive. Distance traveled by the particle depends upon the path followed by the particle in going from the initial position to the final position. Obviously, because distance means, if I travel from, let's take the very same example, started traveling from Kolkata, I went till London, I came back to Delhi. So my distance traveled would be from Kolkata to London plus from London to Delhi. That would be my total distance traveled. Whereas what would be my displacement? My displacement is going to be from Kolkata to Delhi, because that is the only thing I care for. I don't care whether I've covered London, whether moved to America, whether I moved to Bangalore. That is not my point of concern in while I'm considering displacement. But for distance, it is very vital. Whichever path I have covered, whichever path, through which path I have traveled, and what exactly is the length I traveled during my entire section, I can say, then distance is is actually the entire path that I've traveled. It concerns my path, but displacement doesn't concern my path. It only concerns my initial position and the final position. So you can take a note of this distance, of this difference. And the last one is distance is a scalar quantity, because as I say, it only considers your magnitude. It doesn't care about direction. So it is a scalar quantity. I hope you guys know what is a scalar and vector quantity. If you don't know, and if you want me to make a video on it, please let me know in the comment section. I'll make another video on scalar and vector quantity. For now, distance is a scalar quantity because it has only magnitude, it doesn't have a direction, while displacement is known as a vector quantity because it has both magnitude and direction. Like I said in case of while explaining the negative direction, that if it takes one direction as its positive, the opposite should be its negative. So that is why velocity is known as a vector quantity. Let me know if you need a video on this. I'll cover this part as well. Thanks for watching. In the next video, we will cover speed and velocity. Keep watching, keep following, and if you need any specific video or any specific topic, let me know in the comment section. I'll try to cover that. Thank you.